All right, so we're looking at this year is 2018 paper. So we're gonna go to June 2018, nice and easy. So of course, you know, you have the formula sheet. You have the formula sheet and all right. So let's get into it. It says, given that the function f of x is x squared minus 4 and x is greater than or equal to 0, it says find the inverse of the function and state the domain of the inverse. So to find the inverse of this function, first thing you do is interchange x and y. So you're going to say x is y squared minus 4. Generally, I don't like to say y squared, so you can say f inverse minus f inverse all square, f inverse all square minus 4, and that's equal to x. Then you're going to make f inverse the subject. So you add 4 to both sides until you get x plus 4 is equal to f inverse all square. And in order to get rid of the square, you just square root both sides. So what we're saying is f inverse is the square root of x plus 4. So you can write that down at f inverse, hence f inverse of x is equal to the square root of x plus 4. And then this question, look what it asks us for. It asks us for the domain. Now, first and foremost, the domain, what's going to be the domain? The domain has to be, look how we're going to find the domain for this. First and foremost, square root have to be positive, right? We know, so the square root of x plus 4, this always have to be greater than or equal to 0, right? So this has to always be greater than or equal to 0. So if you square both sides, in reality, x plus 4 gonna have to be greater than 0. So we can write that down that x plus 4 have to be greater than or equal to 0. And so the domain then is x has to be greater than or equal to -4. All right, so this is the domain. So you can make them know this is the inverse function and this is the domain. So x has to be greater than or equal to -4. So this is the domain of the inverse. Nice and easy. Tell them that I domain. Soft. All right, let's continue. Now it says now on the grid provided, it says sketch f inverse of x. So remember, we just said that f inverse is the square root of. All right, let me just write it down. We just said that f inverse of x, f inverse was, I believe, the square root of x plus 4. This is f inverse. I said that the domain started from what? Domain started from -4. When x is -4, -4 plus 4 is 0. So when x is -4, y is 0. Then put in -3. When x is -3, you get -3 plus 4. -3 plus 4 is -3 plus 4 is 1, and the square root of 1 is 1. Then you put in 2. 2 plus -2 plus 2 is 2. And so you get the square root of 2. The square root of 2 is 1.43, somewhere about here. All right, then you put in -1. -1 plus 4 square rooted, that's 1. Negative square root of 3 is 1.7. Then you put in when x is 0. When x is 0, the y value is 2. put in when x is 1. When x is 1, you get square root 5. Put in when x is 5 now. 5 plus 4 is 9. Square root of 9 is 3. Alright, so if I'm to sketch a graph, it looks something like this. Alright, that's how the inverse looks, something like that. Then it's going to say state the relationship between the inverse and f of x. Now the relationship is that there are reflection in the line y equal x. So I'm just going to draw the line y equal x right here. Alright, let's draw the line y equal x. This is a line y equal x. Alright. And so as you can see, this is a reflection of this. The two functions are a reflection of each other. And so we say the relationship between f and its inverse is they are a reflection of each other in the line y equal to x. They are a reflection of each other in the line y equal to x. Nice and easy. Part B, it says, derive a polynomial of degree 3 which has roots 1, 2, and minus 4. So to derive a polynomial of degree 3 and it's p of x, so we can say p of x is equal to x minus 1 times x minus 2 times x plus 4, because it's a x equal minus 4 is a root, and so p of x is this. All right, so now all we need to do is expand this. So you can expand this now, x minus 1 times x minus 2. I don't even need to do that. Well, there are two ways you can do it. Let's do it both ways. All right, this is p of x, and they want you to expand it out. There are two ways you can find what is p of x. First method you can use is known as sums and products of roots. You can write this. So you can write that p of x is equal to x cubed minus the sum of the roots times x squared. I'm going to write x minus the sum of the root times x squared plus the product of the roots by 2 times x minus the product of the 3 roots. This is how you find p of x. All right. Now the sum of the roots mean you add 1 plus 2 plus negative 4. And so what you get is x cubed minus, now 1 plus 2 is 3. 3 plus negative 4 is negative 1. Negative 1 become plus 1. So this becomes x cubed plus x squared. Then here, so now we have p2 mean the product by 2. So we're going to multiply 1 times 2 plus 1 times negative 4 plus 2 times negative 4. And so we get negative 10. This is minus 10 times x plus the product by 3. So now negative 4 times 2 is negative 8 times 1 is negative 8 minus 8 is plus 8. And so that's p of x. P of x is now x cubed plus x squared minus 10x plus 8. That is p of x. All right. Nice and easy. Nothing to worry about. Nothing at all. Nice. So that's p of x. Now that we have p of x, what are we required to do? Now that we have p of x, that's it. Now let's say you wanted to expand it out. You could multiply it out and you get the same thing. So up here you could multiply it out by saying x minus 1 times x minus 2. That would have given you x squared minus 3x plus 2 times x plus 4 and then you'd have to expand out this again, and then that would lead to the same result as what is down there. So it depends on which method you want it to take. All right. Depends on which method. You could use factor theorem and do it, or you could use sums and products of roots and do it. Let's look at part C. Part C now. Part C is, it is saying an equation relating V and T is V is equal to KAT, where K and A are constants. And it says use logarithms to derive an equation in the form y equal mx plus c that can be used to find the value of K and A. So use logarithms to find equation in the form y equal mx plus c. Now, all right, so V is equal to this. So first thing it says use logarithm. So we can take logs to say that log V is equal to the log of, it's equal to the log of K A to the T. All right. Now, if the log V is equal to log Ka to the T, then what we're saying then is, this implies we can separate it by saying then that log V is equal to, we can rewrite this as log K, we can rewrite this as log K plus T times the log of A. All right, so that's all we're saying. So in conclusion, I'm just going to write it better. We're saying that log V, this is like your y. I'm putting a bracket around it to show that this is like your y is equal to T log A and I'm going to put a bracket around log A because I want it to look like this is your M, T is your M, this is your X plus C, and your C will be log K. Just wanted us to see the Y, the M, the X, and the C. All right, and it says if a graph of Y versus X from equation C1 is plotted, a straight line is obtained. State an expression for the gradient of the graph. State an expression for the gradient of the graph. Now, what are we saying? Now, the gradient will be M. And so from this that we have above, the gradient is T. All right? So we can tell them that the gradient is T. That's the gradient. If we were to plot a graph. Nice. Question 2. Question 2 says, given that g of x is minus x squared plus x minus 3, express g of x in the form a in bracket x plus h squared, where a, h, and k are constants. So first thing you have to do is find what is h. H is equal to b over 2a, so it's going to be b, which is 1 over 2 times negative 1, so it's 1 over negative 2. That is h. Next thing you have to do, or next thing we have to do, is find k. K is 4ac, so it's 4 times a is negative 1, times c is negative 3, minus b squared, so it's minus b, which is 1, square over 4 times a. And that's where you use to find k. And that a is negative 1, so it's 4 times negative 1, which is negative 4. So what are we getting for k? So we're getting for k 4 times negative 1 times negative 3 minus 1 square divided by negative 4. So getting negative 11 over 4. So get minus 11 over 4. So then what am I saying? What I'm saying to you then is g of x is equal to a which is negative 1 in bracket x plus h. So this becomes x minus a half square plus k, which is minus 11 over 4. So this is g of x in vertex form. Nice and easy, soft. Now I'm just checking over the values to make sure they're absolutely correct. It is absolutely critical that you always check that you didn't make any calculation mistake. All right, so we didn't. K is correct and H is correct. All right, nice. Now we can move on. And it says, on the grid provided below, sketch the graph of g of x, showing the maximum point and the y-intercept. So the maximum point is going to be when, now it's minus h. The maximum point occurs at minus h. So if this is minus a half, h is a half, so this is a half. So look for the point a half. This is a half, and then we'll look for when y is negative 11 over 4. Negative 11 over 4 is negative . Check this again. 4 times minus 1 times minus 3 minus 1 divided by 4a I'm getting negative 2.75. That's, let me see, this is negative 2, this is negative 3, negative 2.75. I don't like the scaling because it's really difficult to find 2.75. 2.2, 2.4, 2.6, 2.8, so 2.75 will be somewhere here. I don't like this scaling. So this will be the maximum point. All right, that's the maximum point. Then it cuts the y-axis at negative 3. All right, so we can sketch the graph now. It cuts the y-axis at negative 3. So this is how the graph looks. All right, that's the graph. Next thing it asks is, whoa, we don't even want nothing else. Just want to sketch the graph. So that's the graph of g of x. It has no roots, it just has the maximum point. It says showing the maximum point and the y-axis intercept. So the y-axis intercept is shown, which is negative 3, and the maximum point is right here. So now, next part of the question, it says, in a geometric progression, the third term is 25, and the sum of the first and the second is 150. Determine the sum of the first 4 terms. Now, for any geometric progression, any term in a geometric progression is given by AR to the n minus 1. So the first term is A, the second term is AR. All right, so this is the sum of the first 2 terms. First term plus the second term, and that's equal to 150. That's what it said. The first term plus the second term equal 150. Then it tells us the third term. So the next equation that they give is the third term, which is AR squared. The third term is 25. Nice. So now we can use these two equations to find A and R. All right, so let's go ahead and do that now. In my estimation, it's easier to make A the subject. And so if AR squared is 25, then I can say, okay, then A is equal to 25 over R squared. That look way easier to me to use. We can substitute A into the original equation. And so what we then get is that A is 25 over R squared plus, now A times R is going to be 25 over R squared times R, which then works out to be 25 over R. And then the material said that equal to 150. That equal 150. So if this is equal to 150, what can we do? We can then multiply through by R squared. So if we multiply through by R squared, we will then get 25 plus 25R is equal to 150 R squared. All right. Now we're going to use this equation to solve for R. I divide through everything by 25 and bring to one side. All right, so dividing through by 25, 150 over 25, 150 over 25 is 6. So I'm getting 6R squared minus R minus 1 is equal to 0. Now this might not look so familiar. All I did was bring everything to this side and then divide it through by 25. All right, so let me put that in right there. Now 6R squared minus R minus 1 equals 0. And now we need to solve for R. Solving for R, I'm just going to go straight to quadratic formula. Solving for R is equal to 1 plus 1 minus the square root of b squared minus 4ac, which is 1 minus 4 times 6 times negative 1, which is 1 plus 24 over 2a, which is 2 times 6, which is 12. And so R is working out to be 1 plus the square root of 25, which is 5. 1 plus 5 is 6. And so R is working out to be 6 over 12. 6 over 12 is a half. All right, so I get R is a half. Now that them finally make we get to find R, we can find what is A. Because A is 25 over R squared. And so A is going to work out to be 25 over a half square, and a half square is a quarter, and 25 over a quarter is, let me put that in the calculator, 25 divided by a quarter, that's 100. Should have clearly seen that, but that's how it goes sometime. All right, so that's 100. So now we can find the sum of the first 4 terms. So let's find the sum of the first 4 terms now. The sum of the first 4 terms, I like to call it S4. S4 is equal to the first term 100, A plus AR squared, which is 100 times R squared. 100 plus A times R, and R is a quarter. Wait, what is R? A half. So 100 plus 100 times a half plus 100 times a half square plus 100 times a half cube. That's the sum of the first 4 terms. So when I add up all of these, that will give me the sum of the first 4 terms. So 100 plus 100 times a half plus 100 times a half square plus 100 times a half cube. So I'm getting 187.5. 187.5. That's the answer. 187.5. Nice and easy, soft. Now this question says if alpha and beta are the roots of this equation, determine the value of 1 over alpha squared plus 1 over beta squared. They want the values of 1 over alpha squared plus 1 over beta squared. So to work out this now, we want the value of 1 over alpha squared plus 1 over beta squared. One over alpha squared plus 1 over beta squared. Now, first thing is when you add in these things, just find the LCM. Please, I'm begging you. Find the LCM. Find the LCM. The LCM between alpha square and beta square is going to be alpha square beta square. Then alpha square into alpha square beta square leave beta square plus beta square into alpha square beta square leave alpha square. So now we need to find out what is alpha square plus beta square and what is alpha square beta square. All of this is just going to work out to be alpha square plus beta square over alpha beta all square. That's what this is going to work out to. Now what is alpha plus beta all square? Alpha square plus beta square is the same as alpha plus beta. This is going to work out to be alpha plus beta all square minus 2 alpha beta over alpha beta all square. Now alpha plus beta, as we know it, alpha plus beta is actually, what is alpha plus beta? Alpha plus beta is minus b over a. All right, so alpha plus beta is going to work out to be minus b, which is minus 5 over a. So alpha plus beta works out to be 5 over 2 square minus 2 alpha beta. Alpha beta is c over a, which is 3 over 2. And then we're dividing that by 3 over 2 square. So you go ahead and you put all of this in a calculator, and then you get your answer. Nice and easy. So you put this in a calculator and you get your answer. So let's just put it in our calculators real quick. So we have 5 over 2 square minus 2 times 3 over 2. And that's 3 1/4. And we divide it by 3 over 2 square. And so we get 1 and 4 over 9. I'm going to write it as 13 over 9. Nice and easy, soft. Question 3. Question 3 says determine the equation of the circle